Hi everyone and welcome to Dr. Jankilo's lectures. Today's lecture is about going over some examples per the previous lecture where I went over the difference body weight, the ideal body weight, adjusted body weight, and the total body weight. And we went over in the previous lecture in between the difference in between these body weights and when to use them. Today we're going to go over these three examples to better understand how to apply these different body weights into actual example, patient examples. So let's get into it. So example number one says, we have a male patient who is 5'7". So patient is 5 feet and 7 inches and weighs 240 pounds. Is to receive 10 milligram per kilogram per day. So this is the dose of theophylline, and that's the medication. What is the daily dose? So the question is, what is the daily dose per this information? So number one step we said yesterday was to calculate the ideal body weight first. So let's do that. So we have 5'7". One thing that is very, very important when we're solving this question is basically always to figure if it's a male or a female, because the formula for calculating the ideal body weight is different. And this is really important to keep in mind. So let's look into this. Since it's a male, so the ideal body weight formula or equation would be 50 kilogram plus 2.3 multiplying, and this is kilogram as well, multiplying by the number of inches above 5 feet. So we have 5 feet over here and then we have 7 inches. So we're gonna plug in here 7 because that's the number of inches after 5 feet. So we're gonna close these with another parenthesis just to know this is a multiplication. So we do this first step and then we jump into addition of 50 kilogram. So 2.3 times 7 is basically 16.1 kilogram. And we have 50 kilogram over here. So the addition of these two would be 66.1 kilogram. So now we have the ideal body weight over here, right? Step number two would be basically to convert these pounds to kilogram. And remember, the conversion factor in between the kilogram to pound is basically for 1 kilogram, there are 2.2 pounds. So this is important to keep in mind when we're doing this conversion. So now we know that. So let's divide 240 pounds. So we have 240 pounds over, or actually let's do it this way instead of doing over, multiplying by 1 kilogram over 2.2 pounds. So pound goes with pounds. Now 240 divided by 2.2, if we're gonna do this in a calculator, you should end up with 109 kilogram. So now I have the actual body weight in kilogram and I have the ideal body weight. So step number 3 in this case would be to divide, to find out first of all, what is the patient? Is he underweight, normal weight, or patient is obese? So let's find that out. So we have the formula for doing that. Let's remember from previous lecture was, so total body weight over ideal body weight multiplying by 100%. So this is the formula to figure out if patient is underweight, normal weight, or obese. And this is really important. So this is what we're gonna do right now. So let's divide 109 over 66. So if you would to follow this formula, it's going to be 109 kilogram, that's the total body weight or the actual body weight, over 66.1 kilogram. And then what are we gonna do? Basically, we need to multiply this by 100%. So if you were to plug in this in the calculator, you should end up with 165%. And what we said from yesterday, anything that is below or equal to 89%, basically patient is underweight. And so let's write it over here. Let's pick this area. So anything that is equal or less than to 89%, patient is underweight. And if it's 90 to less than 120, this is normal weight. And if it's above or equal to 120%, so these are percentage over here, then this would be obese. So okay. So these are the 3 rules that I covered in the previous lecture. So looking at this in comparison to that, basically it's obvious. It's 165 is above 120, therefore patient is obese. So what we said yesterday, in most cases, when we have a patient who's obese, we're gonna end up using adjusted body weight. Because they're obese, we're trying to adjust their body weight. However, we did mention 4 medications. One of them was theophylline. So we have acyclovir, levothyroxine, and theophylline, and aminophylline as well. These 4 medications, if you are not underweight, so anything in between 90 to over 120, basically anything 90 and above, you will end up using ideal body weight, not the adjusted body weight. So in this case, we do not need to calculate the adjusted body weight because we have theophylline over here. And this medication, one of the exceptions for this medication is basically anything above or equal to 90%, we're gonna end up using ideal body weight for the dosage. So this is really, really important. Keep this in mind. During exams, I know there is so much stress, so you may end up not thinking about this point like, oh, patient is obese, let's go adjusted body weight. Yes, this is for many medication except these 4 that I just mentioned. And I will leave the link in the description below for the previous lecture just to give you an idea so you can go back and listen to that lecture. So in this case, we're gonna end up using ideal body weight. So what is the ideal body weight? So ideal body weight in this case is basically 66.1 kilogram. So let's multiply this by the daily dosage over here. So which is, so here, let me use a different color. So we have 10 milligram per kilogram per day. And we're gonna multiply this by the kilogram dosage over here. So multiplying by the ideal body weight, which is 66.1 kilogram. So kilogram goes in with kilogram. So basically 10 times 66.1, we're gonna have 66.1 milligram per day. And this is the answer for this question. Now, question number 2. What do we have? We have patient female who weighs, so we have a female over here, very important. Formula will be different for ideal body weight, keep that in mind. Patient who weighs 160 pounds, so we have 160 pounds, and she is 5'2", is to receive unfractionated heparin. Very important to keep in mind what is the medication in the question, because things could be different just like we had over here. Instead of adjusted body weight, we end up using the ideal body weight. So we have unfractionated heparin, and it looks like we're doing a bolus dose, so 80 units per kilogram. This is the dose. How many units patient will receive? So we're trying to figure how many units will this patient receive per this dose. So first of all, we said we're gonna go over and calculate the ideal body weight. So let's see over here. So since this is a female, so the formula for ideal body weight, it's gonna be different. So ideal body weight it's going to be, instead of 50 over here, right? It's going to be 45.5. And then plus parentheses 2.3 kilogram. Of course, this is a kilogram over here as well. And then time. So what do I need? 2. So we have 2 inches over here. About 5 feet. So 2.3 times 2. So let's move it over this area over here. So it's going to be 45.5 plus 4.6. So 2.3 times 2 is 4.6, and these both of them are kilogram. So the addition of these two, so 45.5 plus 4.6 is going to be 50.1 kilogram. So this is the ideal body weight down here. So this is where we said we're gonna do as first step. Step number 2, we have it in pounds. Where is the weight? 160. So we want to convert this to kilogram right now. And don't forget, this conversion factor is right down there. So let's look into this. So we have 160 pounds multiplying by 1 kilogram is equal to 2.2 pounds. Take pounds with pounds. Now 160 divided by 2.2 is basically 72.7 kilogram. And this is this is ideal body weight, and this is the total body weight or actual body weight, same thing. So now I have both of them. Now what we need to do is basically the third step, which is following dividing total body weight over ideal body weight, multiplying by 100%, trying to figure where the patient is at, underweight, normal weight, or obese. So let's do this next. So what are we gonna do? We're gonna divide 72.7. So here, 72.7 kilogram. Dividing this by the ideal body weight, which is 50.1 kilogram, multiplying by 100%. Now, so if you were to follow this, plug in this in the calculator, you should end up with 145%. So again, looking at this, we have 145, and we said anything above or equal to 120%, patient is considered obese. So in this case, we know patient is obese. In most cases, what we're gonna do, we're gonna use the adjusted body weight. However, again, we have another medication that has an exception. Remember, there are 3 medications. If patient is obese, over or equal to 120%, we're gonna end up using the total body weight or actual body weight. And these 3 medications, one of them is unfractionated heparin, basically heparin. So unfractionated heparin, low molecular weights heparin, and then vancomycin. Remember these. I covered these in the previous lecture as well. So in this case, even though the patient is obese, we're gonna end up using the actual body weight, which is 72.7 kilogram. So let's see over here. So to calculate the number of units, so we have, let's change in color. So we have 80 units. And we have this per kilogram, right? So kilogram. And then we're gonna multiply this by the total body weight, which is 72.7 kilogram, which is just right here. So kilogram goes with kilograms, right? So now 80 units times 72.7. If you were to multiply or plug in this in the calculator, you should end up with 5,816 units. And these are the numbers of unit patient will be receiving of unfractionated heparin. And this is the answer to this question. Now, let's move in to question number 3. Question number 3 says, male patient, okay, so we have a male, so we know we're gonna end up using this ideal body weight equation down there, is to receive gentamicin. Okay, so a patient has an infection, is going to be receiving gentamicin 4 milligram per kilogram per day. So this is the dose. Patient is 110 pounds. So we know patient's weight is 110 pounds and is 5'5". So 5 feet and 5 inches. What is the daily dose? So again, what are we going to do in this case? Step number 1, ideal body weight. So let's do that first. So where we have 5'5", so it's going to be, so ideal body weight, just like previously, it's 50 kilogram plus parentheses 2.3 times number of inches, which is 5. And this is kilogram here too, closing the parentheses, and then, so we need to multiply 2.3 by 5 first, then add 50 kilogram to it. So 2.3 times 5 is basically 11.5. So here, let's move in this step over here. 50 kilogram plus 11.5. And the addition of these two, it's going to be 61.5 kilogram. So this is the ideal body weight for this patient. Now, let's figure step number 2. What is the weight, the total body weight or actual body weight in kilograms? So we have 110 pound. Don't forget the conversion factor. I keep pointing these conversion factors here and there because they're really important. And during exam, you will sometimes you may end up not remembering these conversion factors. They're very small details, but they're super important. So let's see over here. So we have 110 pounds. So 110 pounds multiplying by, for each 1 kilogram, there are 2.2 pounds. So taking pound with pound. So 110 divided by 2.2 is basically 50 kilogram. So this is total body weight. Okay, this is it down here. Now, what is the step number 3? Step number 3, basically trying to figure where patient is at. So let's do that. So we have 50 kilogram over here, which is the total body weight, dividing this over, let's see, where's the ideal? Oh, 61.5 kilogram multiplying by 100%. So if you were to plug in this in the calculator, you should end up with 81%. So looking at this, 81% is basically less than 89. Therefore, in this case, patient is considered underweight. And what we said last lecture, when patient is underweight, we're gonna always, and for all medication, there are no exception in this case, we're gonna end up using the actual body weight or total body weight, which is 50 kilogram down here. So let's do this. So we have, what is the dose? The dose is 4 milligram. 4 milligram per kilogram. And this is daily, per day. Multiplying by 50 kilogram, the actual body weight. So kilograms goes with kilogram, and then 4 times 50 is basically 200. So patient is receiving, or will be receiving, 200 milligram per day. And this is the answer to this question. So this is it for this video. If you have any question or comment, please leave them in the comments below. And as always, thank you for watching.